Last week we talked about our motor installation, and we are back to visiting the great, one of the most common call for tech support scenarios on the planet. Either one of these closed?
Yes, I will.
Okay, all right, so if I turn this on, is this the one on?
Call tech support.
No, this one is off. So this thermostat controls what damper?
I will.
Yes, great. That's great. It's not closed all the way because we were experimenting with the set points that you can leave it open. Before we move on from that, why would you leave set point? Why would you change the set point on the back? Let me show you that. Why would you ever do that?
Static pressure. Static pressure.
Yep. So if you had a really small zone and your system, large system dumping a lot into a small zone could be a major static pressure issue, airflow issue. So you could keep the large zone partly open. It never fully shuts all the way. And then you have your small zone that's still going to probably satisfy quick enough before the big zone becomes uncomfortable. If you have a working spillover, the bypass system, you probably don't need to do that. But yeah, that's another possible solution to
unless it's all bypassing directly into the return.
Right, even then, if it's a small zone, you should be able to cool that zone before it freezes.
What if my
you got
2065?
You got, yeah, exactly.
That's what they do with the vacation homes.
Yeah, this is one of the issues with our zone systems. You do have vacationers putting in at 65 and you have a really tiny zone, it will freeze. Yeah,
Or the DAT sensor goes
that's
off.
really good.
Or
the DAT sensor, yeah. Yeah, excellent. So I have actually, I'm glad you brought that up. I have used, instead of a DAT sensor, a freestat on the coil and tied it in so that it's basically, it has the same function, but we're only shutting this thing off on freeze. And then just say basically good luck when it comes to heat. I hope things go well. We don't have the DAT sensor in heat. So you could put the freestat as a float switch to kill main power, but then constantly have things coming off and resetting. You don't want to do that anywhere in the vacation area where they might have alarm thermostats that reset to heat pumps or to a non-heat pump system every time it kills power. But yeah.
Break yellow?
No, you could, but I also don't like that. I don't like a compressor coming on and off, so yeah. You could break red on a damper system, that would be fine. But my favorite way is just to tie it in where the DAT sensor is. Or I'm sorry, don't ever tie it in where the DAT sensor is.
Resistance.
You can break orange and heat the coil back up.
It is red. I'm trying to think of, last time I did this was in Legends for a guy that keeps it really cold upstairs. And it was red, it broke red.
To the equipment?
To the equipment, yeah. So if you break, that's what it is. If you break red to the equipment, you're not resetting your thermostats because it's on a different power.
On a real note, why not break orange? Heat the coil back up. Let's go back to cooling.
Such a really terrible idea. So great.
Noise when that thing slams.
All right, let's get straight down to it then, okay? So our damper system can be very overwhelming, tons of wires. You often are showing up when multiple people have been involved and changed stuff and messed with stuff. Sometimes you have new colors being introduced because someone thinks there's a short, they just don't understand the system. So when you're dealing with a damper system and there's problems, it can get overwhelming. I think the most important discipline in overwhelming diagnostics in general is to stop and say, what do I already know, and how can I use my senses and the knowledge I already have to figure out what's going on. And so you start with what's most simple. How's my filter look in the system? Are all my thermostats cooling? Do I have airflow? little ladder under a vent, do I have airflow? Use your hand to figure out if you have airflow. And so using your senses and very basic stuff, is the equipment running, is the thermostat on, filters clean, things that you already know how to do well is always where you need to start on diagnostics. Our tendency is we have a gray area, something that's confusing or frustrating. Our tendency is to assume that's where the problem is, because that's the area we don't understand. So we kind of, okay, the board's the issue because I don't really know how to confirm that, but what we should do is start with what we know for sure, what we've already been trained on, what's already second nature to us, and assume that the problem is a simple, straightforward fix that you can find. If you cross all of those boxes off and you come back and you still have an issue, that's when you can start looking at the board. Another thing with the damper systems that we need to all remember is that the best way to diagnose issues with airflow, with the damper motors and their controls is in the house, not in the attic, right? So in the house we have our damper board, in the house we have our thermostats, and we have our vents for airflow. And so turning on the thermostats, confirming if there's airflow, turning off one of the zones at a time, and seeing if that zone closes and airflow stops with your hand. Coming back and if it's not responding and finding out if we have voltage going to our motors on that zone. All of that can be done without going into the attic. Even if you're in the attic and you're looking at the motor turning, you don't even know if it's turning the damper. It could be loose on the damper shaft. Has anybody had that?
Mm-hmm.
Yeah, that's a tricky one. Your motor's spinning, but the set screw that is supposed to be tightened to the shaft is loose. So the motor's spinning, but the damper's not. Typically the airflow will push that damper closed and the motor will spin open and nothing will happen. So yeah, even if you're in the attic, you don't see that unless you open the ductwork. But if you're down in the home and you turn on that thermostat and the airflow doesn't come out, you already know what's going on before you get up there. And you know when you actually need to get up there. There's a lot of time that can be wasted assuming that there are difficult problems before you've checked the most basic. So that's what that is. All right, let's talk about understanding the damper system. What's the E stand for up here?
Equipment.
Equipment. That's right. And our equipment is our air handler and condenser and control system. And the equipment is powered by 24 volts that comes from the factory transformer inside our air handler. Right? So if we want to pull in our condenser contactor, we can't use yellow from one of our thermostats and wire nut it to yellow in our air handler because it's a completely different 24 volt power source. The yellow tied in at our condenser is going to have common coming back to the transformer that comes from the factory of our air handler, right? So in order to control the equipment, we need the equipment's red coming to our equipment terminal. And then just like with the thermostat, the damper board functions in the same way. When you have your signals to run and everything's in its proper place, red just jumpers to the other terminals in order to call your different modes. Okay? So this 24 volts coming in here is not used to call our equipment. It's the red from our air handler that is used to call each one of these. Does that make sense? Okay, great. I get a lot of calls where red is broken by a fuse or a flow switch. Again, something we already understand. It's very simple. But I'm getting a call from someone who's been there 30 minutes trying to figure out what's going on because they didn't check the float switch or the fuse, some very basic things. Why in this situation were they not looking at the float switch or the fuse if, let's say for instance, the float switch is tripped and red is broken right here?
Power to the board.
There's power to the board, yeah. Which in their experience, what are they seeing? It's making them think that it's not a float switch.
Yeah, thermostat's not
Yeah,
working.
thermostat's out of display, it says it's calling, so you're not thinking float switch, because we're not usually walk in and we have a blank thermostat when it's not its own system. And so when you actually have red killed powering to the equipment, so some safety is keeping red off, everything here is going to be functioning normally. Your motors will open and close. Your thermostats will have a display, they'll be calling, but your equipment's just not turning on. And so what ends up happening there is that guys will grab their meter and they'll come in and they'll try to figure out if they have voltage. It's not coming on.
Did you really just turn it on?
I might have.
Good habits.
Let's first check the ground for safety. We're gonna try to figure out, okay,
Wrong comment.
right? I don't have voltage, what's going on? Okay, maybe we'll do this.
Still.
It's still showing me 0 volts up there. And so the frustrating experience often is, like, okay, there must be something wrong with the board, because everything else is doing its job, but I'm not getting power on these terminals like I'm supposed to. And it's because none of this power gets sent on the terminals. It just controls the switches that open and close connecting R to here. A lot of the new boards now have common on here, and if it's tied in all the way back to the elevator, you can use it to find out if you have 24 volts in the terminals. If it doesn't have common, how do you find out if you have 24 volts on Y?
Check the ground.
Check it to ground.
No, there's usually no ground.
Check it.
Find metal? Okay, we don't have metal in this scenario.
Okay, fine, well then check it to R and you should have 0.
Okay, that is the way. If you have 24 volts on Y, then you check between R and Y and your meter shows you 0. That means you have 24 volts on Y. Because your meter will show you the potential difference between these 2 points. Electrical difference, it measures electrical difference. If both wires have the same 24 volts on them, it'll show you 0. This is another reason why when we go to check safety on a condenser, we don't check from leg to leg before we touch it. We check from leg to ground, right? Because we're ground. And there may be 0 volts from leg to leg because they both are energized with the same line of power. But we're ground and we're about to touch it, there's a potential difference between us and that wire. So we check to ground before we touch things. So on here, our meter is showing us that there's 0 potential difference between R, G, Y, and O. We're calling equal mode. Or we have 0 power on R and it's telling us 0. So to confirm that, check between R and W. We know we're not calling W in cool mode. R and W should have 24 volts. R and O, 0. Okay, I know I'm calling my reversing valve. Great.
Would it be 24 or would it be 12?
12, yeah.
It's 24
will-
would be the ground.
Yeah, but it'll typically show you 24. Remarkably so. Yes. I don't pretend to understand it. Actually, I do know exactly why, but
Why?
I'm going to keep it myself. The reason is because W is tied into a relay, and the relay is tied into common on the opposite side of that.
But it really have to be
And
energized.
so that common, it didn't have to be energized.
Contact.
It's still a path through there. The relay's not pulling in because there's no flow, but you still have a path all the way through the relay to common.
Oh. You didn't say that yesterday.
Just figured it out. You asked the right question. Great. All right, so let's talk about a scenario where they say that the homeowner's confused about what's going on with their damper system. They think there's an issue. You turn everything on, unit looks right, turn it off, it all turns off. You don't really see any issues. but they're convinced there's something going on. Another confirmation that you should do on a damper system is to turn all the zones on and then turn them off one at a time. So while the other zones are running, you turn one zone off and you confirm airflow stops in that area. It's really common to have a thermostat tied into the wrong motor, and it takes just the right scenario for it to notice. A lot of times in the summer, multiple zones are calling at the same time, so you may not notice. And every once in a while, when one should be shutting off, it stays on a little longer than it should and overcools in the space, customer gets comfortable. Or when one should be calling, it doesn't call until the other zone gets hot and calls. And so you don't always catch it, unless you turn all your thermostats on, one zone off at a time, and you confirm with your hand in that area, your handometer. This guy really wanted me to say that all day long.
I did, that was the money one.
Confirm with the handometer that we actually have airflow or don't have airflow appropriately in that zone. And so if you have a scenario where the T-stat1 is not actually controlling zone 1, how do we fix that problem?
Swap wires.
Swap wires where?
At the board.
At the board. We don't crawl up in the attic and start moving wires from one motor to the other, right? We just go right here and unplug that wire, plug it in with the other thermostat, swap it around, go straight back and confirm. And now we know we need to do that with every single zone in the house. There's likely some mix-ups going on there, right? Setup on your system, we're gonna run into this a lot in heating season. There are multiple ways that you can set up a damper panel to control heat. If it has a setup rather than the preset, so the step down in Honeywell's or a cheaper version of the board, it has preset every once in a while, just maybe a jumper. This one has a full setup you can go through. But
Usually the two zones don't have control. Like
yeah, so the two zones, they're all controlled by the thermostat. So if you have O plugged in, it's a heat pump. If you don't have O plugged in, it's conventional. Whereas this, you have the ability to use this board and wire it up as conventional. You can have a conventional thermostat, but it still control a heat pump system. And so you can go into the install settings and say thermostat 1 is conventional, thermostat 2, heat pump. And then it will control, if thermostat 1 calls for heat, it'll de-energize O. Even though thermostat 1's not getting any type of O communication. So where this becomes a problem is that we haven't properly set it up as a heat pump. Or we have one thermostat set up wrong and it keeps calling, energizing the O valve when they're trying to call heat in other zones. So just pay attention when you have issues with heat not calling through the winter. You can configure the damper board for the equipment that you have, and you might have to reconfigure thermostats to match that. Let's try to keep everything consistent. Let's not do here's a conventional and a heat pump on the same thing if we don't have to. Let's try to keep it consistent throughout the house. So just be aware of that. You will run into that. I got a lot of those calls last year.
And when you say conventional, what does that mean?
Okay, so conventional means thermostat that is not going to be using an O wire. And so it's just controlling heat with the Y call, or with the W call, and cool with the Y call. A conventional system, when it calls heat, it doesn't energize Y. It's not calling a condenser. It's only energizing W. And so conventional traditionally is for a furnace system, or a straight cool where you would have only electric heat would be a conventional setup. So you don't want your condenser calling if it's not a heat pump in heat mode, right? Because then you would be running your heat and your cool together. So last year there was a couple scenarios where we had a damper system connected to the AC and furnace setup, and then we had set up the damper panel wrong and we were calling the condenser with our furnace. That's great. DAT sensors, you guys are all pretty familiar with those, to test them. You can look up a 10 kW chart on Google, test your DAT sensors. And you can also unplug the DAT sensor. I don't want to see anybody quoting a DAT sensor and walking away from a system and leaving it inoperable, right? Unplug it, test the system, leave it running. We want to know that's the only problem there, right? And that's the only thing they're dealing with. So when a DAT sensor is an issue, you can simply unplug it. The board will blink at you in frustration constantly, but operation will still be there.
I love how it's called like DAT sensor.
Mm-hmm.
Not this sensor, it's that sensor.
Yeah, it's not this sensor, it's DAT sensor.
That's exactly what it is. Yeah, it's an acronym that stands for.
Discharge temperature.
Nice, great. The limits typically are 45 and 155, preset limits. So in heat, if it goes over 155, or in cool, if it goes below 45. And you can change it on something like this. Anybody know why they would need that on a damper system?
So that one zone gets closed and it starts to freeze out the system. Like if you close the big one and you've only got it going through the little one and you have too much, not enough airflow.
You should be able to,
Wait, what I said.
that should be normal operation though. Normal operation is one shuts down and the other runs. Damper panel has failed closed. We have no airflow, even though it's calling for it to be open, the motor has failed. And we're running heat, electric heat pump. And it's pumping it against the flat wall. That's where the DAT sensor comes in and saves the day, saves the equipment.
First heating need, right?
Okay.
Big cold snap. We'll all be down in
Margaritaville.
Yeah, I was about to say Greg and Andrew.
I ran 10 of those calls on Christmas Eve,
Yeah.
all filled
Yeah.
sensors.
Yeah, they
well-
like to go when heat comes on.
Just something in heat. It's usually heat.
They're not used to it.
Which you can also take them out of circuit, they want those.
Probably has something to do with the type of failure as it breaks down and the resistance increases. Maybe that's induces the thermometer to read
Well, I know this year
that it's hotter than it is, which wouldn't shut you off in cool mode.
Greg Angelo has been replacing them himself,
Yeah,
so.
he got tired of, that. He's been replacing
Nice.
it,
Yeah.
Nice.
so that's great. Any questions on damper systems, issues that you've run into that we can talk about?
Not panel, but I think when we quote one failed motor, quote all of them as a preventative measure.
Yeah.
Because when one goes, the next 2, 3, or 4 zones are also set to follow behind. Let the homeowner know as a preventative measure, because we've gone to, one in Orlando that we've replaced 4 on 4 different visits.
Yeah.
Just quote it all at once, let them know, and then let them make that decision. So then every time we go back out, it's diet plus.
This is oddly consistent. It's oddly consistent that you have an older system, the damper fails, and the other motor is going to be within that next year. They were both installed at the same time. It is oddly consistent, so that's a great practice.
That's really good, Matt.
And when you are quoting the motors, you need to know the style of motor and communicate that clearly, right? We talked about that last time, but the larger shaft, smaller shaft, Honeywell versus Universal. And Universal can be installed anywhere as long as the damper matches. Like this panel's a Honeywell, so it's designed to fit this, but you also have the closed and open both energized from this panel. Last but not least, if you guys work on Infinity damper systems, the motors are controlled 24 volts open and closed, the same as this setup. The only difference is, which is a little bit tricky, and I failed a board that wasn't failed for this, is that when it's done turning, it stops sending the signals. So the board will only send the 24 volt signal long enough that it thinks the damper gets open and closed.
And you can confirm all that though through the airflow verification test.
Yep, and exactly, you can go through it, and they will confirm themselves based on static, whether it's opening and closing, and, But if you're there trying to figure out, is my damper board failed, what's going on here, it's not sending the signal to open, or it's not sending the signal to close. It's only after that initial command change, long enough for the motor to turn, and then it shuts off, stops sending the signal. Whereas this, and pretty much every other board, constantly energizes open or close.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.